Welcome to another physics class. As I promised in our last lesson, that we are going to look at calculation under the topic uniform circular motion. So let's start with this first example. A stone is attached to the end of a string and while round in a circular path of radius 0.5 meter. The stone makes 9 complete revolutions in 3 seconds. Calculate the 1. Angular velocity, 2. Linear velocity, and 3. Radial acceleration. So, from the question, solution. Let's write out the parameter given. The first thing given there is radius, 0.5 meter. Then, number of revolution is given. Number of revolution equal to 9 complete revolution. Then time is given. That is 3 seconds. Now to calculate angular speed now, angular velocity. Angular velocity, Don't forget the symbol. The symbol is omega. And from the parameter given now, we can now say that one of the formula written in our last lesson is theta over time taken. Now, from the question now, time is known. That is 3 seconds. Theta is given in indirect form. Let's find the angle now, that is angular distance. Already we know that one complete revolution is equal to 360 degree or 2 pi rad. Don't forget we done this under the first lesson, under the topic. Then we were given 9 complete revolution. 9 complete revolution will now give us, since we are working in radian, so that's 9 multiplied by 2 pi. That is 18 pi rad. So that is our angle. That is number of revolution. That is for 9 complete revolution. That is our theta. Now, to calculate angular velocity now, omega will now be equal to 18 pi over the time taken is 3 seconds. 3. So this one will now give us 6 pi rad per second. Don't forget the unit of angular speed is rad per second. That's the answer for angular velocity. Since the value of pi is not given, don't forget we said pi is equivalent to 180 degrees, but it's not given. We calculate in terms of pi. Question Roman figure 2 now. 2. This one is linear speed, linear velocity or linear speed. The symbol for this one, don't forget, is V. And the formula from our last lesson, V is equal to omega R. And we know the value of omega. Already, R is given. So that one will now give us, that is 6 pi multiplied by 0.5. And 6 pi multiplied by 0.5 will now give us 3 pi meter per second. 3 pi meter per second. Don't forget the unit of linear velocity is meter per second. Then, question number Roman figure 3, which is radial acceleration. Radial acceleration. And that will be, the symbol is AC, and From our last lesson, we know that our AC, radial acceleration, is equal to v square over r. That is, v here is the linear speed or linear velocity, r is the radius. So this one will now give us 3 pi all into square over our r, 0.5. And this one will now give us 9 pi square over 0.5. Now, the answer to this one will now give us 18 pi square rad per second square. 18 pi square, 18 pi square rad per second square. Don't forget the unit of radial acceleration is rad per second square. So that's the answer to this question number 1. Now let's take this one as example 1 and example 2. A vehicle of mass 800 kg traveling with a speed of 96 km per hour in a circular path of radius 10 meter. Calculate 1. Acceleration of the vehicle. 2. Force that keep the vehicle toward its center path. Now let's list out the parameter. Solution. Mass of the vehicle is given. Mass M, 800 km. The speed V is equal to 96 km per hour. So mark you, the mass is a correct unit, radius is a correct unit. So, but speed is in kilometer per hour. We need to convert it to meter per second. So now say convert 96 km per hour to meter. This one will now give us 96 km to meter. That's multiplied by 1000. Then per hour. 1 minute, 60 minutes is equal to 1 hour, and 60 seconds is equal to 1 minute. That will be 1 multiplied by 60 multiplied by 60. So this one will now give us the speed now in meter per second will now give us 96,000 over 3600. And the answer to this one will now give us 26.667. That is meter per second, because the question it is linear speed, not angular speed. So once we know that the speed now is 26.667, let's approximate it as approximately it will now be equal to 26.7 meter per second. Now, as I said, approximately the answer will be 26.7 meter per second. The first question says we should calculate acceleration. Don't forget, once it is a circular path, the acceleration is always radial acceleration or centripetal acceleration. So, 1 now. Centripetal acceleration or radial acceleration, the formula remains the same. That's v squared over r. And our v is what? 26.7. That will be all to square the radius given here, according to the question, r is equal to 10 meter. So that over 10. So AC, that is centripetal acceleration. Now 26.7 square, that's 712.89. Then divided by 10. So our centripetal acceleration, that will be 7.1289 rad per second square. that is 71.289 rad per second square. Now, to calculate the force that keep the vehicle toward the central part, that's question number 2. And that one exactly will be centripetal force. And the formula for that one will be equal to mv square over r. Or rather, since we know the value of A now, it will now be equal to F is equal to MAC. Since we know the value of radial acceleration, so therefore, this one will now give us 800 multiplied by 71.289. Now the answer to this one will now give us 57031.2. The unit of force is Newton. That's the answer to question number 2. Let's take this one as example 3. The body is rotating in a horizontal circle of radius 2.5 meter with angular speed of 5 rad per second. Calculate the magnitude of radial acceleration. Now, let's write out the parameter. Here now, angular speed is given, that is omega is equal to 5 rad per second. Then radius of the circle 2.5 meter. Now, to calculate the angular acceleration, radial acceleration, AC is equal to V square over R. Now, V is not given. Can I say but V is equal to omega R. So once omega is given, this one is now 5 multiplied by 2.5. So this one will give us 12.5 meter per second. Once we know the value of V now, we can now say our AC now will be equal to 12.5 square over the value of R is 2.5 over 2.5. Now, this one will give us 156.25, then divided by 2.5. So, final answer will be equal to 6. That will be 62.5 rad per second square. That's the solution to this example 3. Let's take this one as example 4. A particle of mass 5 kg moves round in a circle of radius 1.2 meter, making 3 revolutions in 2 seconds. Calculate the 1. Angular velocity, 2. Linear velocity, 3. Centripetal acceleration, 4. Centripetal force. So from this one, let's write out the parameter given. Mass of the particle is given as 5 kg. Again, number of revolution is given as 3 revolution. Time taken, t, that is 2 seconds. Then the fourth question says we calculate the linear velocity. And you know that answer to question 1 now, linear velocity. That is V. V is equal to, the first question is angular velocity. Angular velocity, that is omega, which is equal to theta over t. Like the first calculation we did, theta, that is angular distance, is given in the question indirectly. Let's find out theta now. We have one complete revolution is equal to 2 pi rad. Then we are now given 3 complete revolutions. So 3 complete revolution will be equal to 3 multiplied by 2 pi. So our theta now is equal to 6 pi rad. That is theta. So since we know the value of theta now, then omega is equal to theta over t. That will be 6 pi over the time taken is 2 seconds. 2. That is when we give us 3 pi rad per second. Then to move to question 2, Roman figure 2, linear velocity. V already, don't forget, V is equal to omega r. And for the question, our r is given as 1.2 meter. So if that is the case, and already we know the value of omega, this one will now give us 3 pi multiplied by 1.2. The answer to this one will give us 3.6 pi meter per second. The unit of linear velocity is meter per second, 3.6 pi meter per second. The next question there is centripetal acceleration. 3. Centripetal acceleration. That one will be AC is equal to V squared over R. And our V here is 3.6. This one will now give us 3.6 pi all into square. Our R, according to the question, is 1.2. The answer to this one is 12.96 pi squared over 1.2. The answer for our centripetal acceleration will be equal to 10.8 pi squared rad per meter square. That's the answer to that one. The last question under it asks us to calculate the centripetal force. Mind you, we can also calculate the centrifugal force. Don't forget, in our last lesson, we said they have the same magnitude as mv squared over r. So 4 now, Roman figure 4. That is centripetal force. That is Fc. Since AC is known, better we use MAC. That is mass multiplied by the centripetal acceleration instead of using V squared, mv squared over r. So from there now, we can now say our M, according to the question, is 5 kg. That's 5 multiplied by 10.8 pi square. The answer to this one will be 54 pi square Newton. 54 pi square Newton. That's the solution to example 4. Take this one as example 5. The Earth orbits the Sun with the speed of about 3,000 meters per second at the distance of 1,500 meters from the center of the Sun. If the mass of the Earth is 60,000 kg, and cover a distance of 2,500 meters. Calculate the 1. Angular distance, 2. Angular velocity, 3. Centripetal force. Let us write out the parameter given in this question. The Earth orbits a sun. The speed v is given. Speed v is equal to 3,000 meters per second. Again, the distance r, that is the radius from the center of the sun, is 1,500 meters. Mass of the Earth is given. Mass of the Earth is given as 60,000 kg and cover a distance of 2,500 x. Distance x. Distance cover x. Mass m as 2,500 meters. The first question says to calculate angular distance. 1. Angular distance. Don't forget, the angular distance also is the angle turned through. That is theta. And one of the formula of theta given in our last lesson is theta is equal to, that is S over R. S is given, that is the distance covered. R is given, that is the distance from the center of the sun. So we can now say our S, according to the question, is 2,500. Then the distance from the sun, 1,500. So this one, we cancel this one. We have 25 over 15. And this one we give us 5 over 3. And the angular distance will now be equal to, the angular distance will be equal to 1.666 rad. Approximately, theta will be equal to 1.67 rad. That is the angular distance. Then the second question says we should calculate angular velocity. Angular velocity, which is omega. And we know that omega is equal to v over r. And v is given, that is 3,000. Our r is 1,500. 1,500. 3,000 divided by 1,500. So our omega is equal to 2 rad per second. 2 rad per second. That is for angular velocity. And the last under it is centripetal force. Centripetal force, that is Fc, that will be, according to the question, mv squared over r. M is known, so our Fc now will be equal to, the mass of the Earth is 60,000. 60,000. Our V from the question, that is the speed, is 3,000 square it. Then R is 1,500. Now, this one will now give us 60,000, that's 6 times 10 raised to power 4 multiplied by, this one will be 9 times 10 raised to power 6, all divided by 1.5 times 10 raised to power 3. This one will now give us 54 times 10 raised to power 10 divided by 1.5 times 10 raised to power 3. This one will now give us 4 times 10 raised to power 10 minus 3 over 1.5. So from there, we are going to have, let's continue from this place. Our FC will now be equal to 54 times 10 raised to power 7 divided by 1.5. So it will give us 36 times 10 raised to power 7. And finally, the answer will now give us 3.6 times 10 raised to power 8 Newton. That's the centripetal force. Now, with those 5 examples, I believe you should be able to solve any question under uniform circular motion. But if you still have questions under the calculation or under any aspect under this topic, you can ask from the WhatsApp channel on the link. Let's now move to motion in a vertical circle. That is, when you have an object moving in a vertical circle, what are the necessary things? Let's say this is an object moving around this circular path. When it moves toward this end and toward this end, and the same time toward this end, the centripetal force and centrifugal force that will hold it away and inside will be like that. At the same time, when it is along this place, so let's now label it. When it is vertical, like this, we are going to have it like this. The tension under the spring will come down. At the same time, the weight of the bulb. But when it moves to this side, the weight of the bulb will act downward, the tension will act upward. So from what we've done on the board now, it means when an object is moving in a circular path with constant speed, the centripetal force of the body will be given from the tension on the spring. At the same time, number 2, weight of the object. I think the centripetal force will be given from the tension and the weight of the object. But the total centripetal force, once the object moves through this vertical oscillation, Fc will be equal to mv squared over r, which will be equal to the weight of the tension on the string plus the weight of the object. That will be total centripetal force. But if you now label it as this, let's label this point as A, B, C, and D. When you look at it at point, if you want to calculate the tension at point B now, that is the particular point on this object, then we are going to have the centripetal force. Now say at point B, the centripetal force now and the weight and the tension will be related in this form. That is, at point B rather, we are going to have Fc will be equal to mv square over r, which will be equal to T plus W. So if you call this tension T1 and here the weight as W, the tension here as T2, and the weight acting downward as W. So for at point B now, since both the tension and the weight face the same direction, then we are going to have it like this. They face the same direction. This one is downward. The weight of this object is downward. The tension of this one also is downward. Then we are going to have the total centripetal force like this. Therefore, the tension T1 at this particular point, T1 will be equal to mv square over r minus W. That will be the tension at this particular point. Now, at point D now, we are going to have it as, once we said this distance at point D, look at it, the tension on this string and the weight are in opposite to each other. Therefore, if they are in opposite to each other now, according to the formula, then the centripetal force at point D now will now be equal to mv square over r, which is equal to T2 minus W. Why is it minus? Because according to the law of vector, when you have two vectors move in opposite direction, their resultant vector will be minus. So if that is the case now, since the tension T2 and the weight of the object acting in opposite direction, the total centripetal force will be equal to that. Therefore, the tension at point D now will now give us T2 will be equal to mv square over r plus W. Now, at point A and C, at point A and C, since they are in horizontal, the tension at point A and C will have the same value with the centripetal force. So the tension at point A and C will be equal to centripetal force. Therefore, what are we going to deduce from this one, we can now say that when an object is moving in a vertical circle at point B like this, the tension will have the least value. That is, an object moving in a circular path at the top of the motion, at the top of the motion, that is at point B, it will have minimum tension. At the bottom of the motion, at the bottom of the motion, that is at point D, it will have the greatest tension, which is T2, while this one is T1. Now, in calculation now, because we are going to look at calculation under this one, in which the question will ask us to calculate the minimum and maximum tension when an object moves in a vertical circle like this. Then we need to take note of this formula. Now, let's use these examples to back up the formula written for motion in a vertical circle. Look at the question. A boy swings a small stone tied to a string round a vertical of radius 1.5 meter. The mass of the stone is 0.23 kg and it moves at a constant speed of 20 meters per second. Calculate the centripetal force. That's 1. 2. Minimum tension on the string. And 3. Maximum tension on the string. Now let's write out the parameter given in this question. Radius of the vertical circle. Radius R is given as 1.5 meter. The mass of the stone L is given 0.23 kg. Moving at a constant speed, V as 20 meter per second. So the first question says we calculate the centripetal force. So we can now say 1. Centripetal force SV mv square over r. Our m is 0.23, then multiply by 20 square, then over 1.5. So this one will now give us 0.23 multiplied by 400 over 1.5. C, that is the centripetal force. 0.23 multiplied by 400 will give us 92 divided by 1.5. And our FC, which is centripetal force, will be equal to 61.333 Newton. We said we need to calculate the minimum tension at question number, which is Roman figure 2. And from what we've written the other time, for the minimum tension, we say it be equal to T minimum will be equal to Fc minus W. Fc minus W. That is T minimum equal to mv square over r minus W. And mind you, mass of this stone is given. So we need to find the W. So W now be equal to mg. That will be 0.23 multiplied by 10 to convert this mass to Newton. So this one will now give us 2.3 Newton. So if the weight is 2.3 Newton now, and luckily our centripetal force is given, so the tension for the minimum will be equal to 61.333 minus 2.3. Now the minimum tension will be equal to 59.033 Newton. The last one there is maximum tension. Maximum tension. So that will be T maximum. That will be centripetal force plus weight. That is mv square over r plus W. And we've known the centripetal force and the weight. So that will be 61.333 plus 2.3. And this one will now give us 63.633. So it will now give us 63.633 Newton. With this example, you'll be able to understand the calculation aspect under this motion in a vertical circle. So if we are just given other example, we will just be repeating ourselves. The formula is the same and the method is the same. But if you still have questions, please, as I said, don't forget to ask your question from the WhatsApp link. And if you are new to this channel, please don't forget to like, share, and subscribe for more notification. Now, the next thing we are going to look at is practical application of centripetal and centrifugal force. Practical application of centripetal and centrifugal forces. Number 1, centripetal force keeps planet and satellite in orbital movement. That is, centripetal force keeps planet and satellite in orbital movement. It allows them to move in a constant speed without skip away. Number 2, centrifugal dryer is used in laundry to dry wet cloths. That is, centrifugal dryers is used in laundry to dry wet cloths. That's number 2. 3, centrifuge machine is used in separating suspended solid material from liquid is used in separating suspended solid material from liquid, that is centrifugal machine. Then number four, centrifugation. Centrifugation is used as separating technique Next is differences between linear motion, linear and circular motion. Let's do it in a tabular form. Linear motion, then circular motion. Point number one. In linear motion, object moves in a straight line. And in circular motion, object moves in circular paths. Point number two, in circular motion, it involve linear speed or velocity, while in circular motion, it involves angular speed or angular velocity. Another point, 3, under linear motion, it involves linear acceleration, while under circular motion, it involves angular or radial acceleration. This one is denoted by A, while this one is AC. Under this one, number 4, this one involves, that is linear motion involves horizontal force, in which the magnitude F is equal to ma. This one involves centripetal or centrifugal force, in which the magnitude of the force is mv square over r. Number 5, object moving with constant under linear motion, object moving with constant speed. The acceleration is 0. Under this one, objects moving with constant speed. The acceleration is not equal to 0. Now, this will be the convenient point to stop on uniform circular motion. And I believe you gain a lot under this topic. But if you still have any question, you can ask your question under this topic or any other topic from the WhatsApp link in the channel. And as I said earlier, if you are just joining us in this channel, please don't forget to like, share, and subscribe. So when I upload a new video like this, you will be able to get the